our question is this. So, some of you had this quiz, some of you didn't. All right, so Kara, what did you do first? There's no wrong answer, so what did you do?
I got rid of like the y -5 and put the x's where they.
Yeah, I think that's a great plan. It's my personal favorite, but you don't have to start that way. X cubed over x will reduce x squared on top, right? Now these guys have to go up because they're negative. So 5 are coming up, and there's already 7 up there, which means there's going to be 12 up there. What does that mean? Square root. So I need to square root this 4 and this 9, so that'll be 2 and 3. You good so far, Kara? I'm not sure where you went wrong. And then what do I do when I have 2 exponents like this? What operation is that? That's not I don't square root these numbers.
That's what I did then. Yeah.
I multiply the exponents.
Yeah.
So that would be x to the first and y to the 12th. So that should be your answer. All right, anybody else? Anya?
That one's quite similar to 5B on the you can do this part. So how would you deal with the -1/2?
Okay, so she's asking basically the same question on the other quiz. So I don't know, obviously, I don't know what you were doing, but here's what I would suggest you do. I like to do exactly what Kara did. Forget that for a second. Let's clean up this mess in here. So I can't really do anything with the 25 and the 4, but what happens with the x's? X squared on top. And what happens with the y's? Same thing as before. These are coming up, so it'll be y to the 12th. Now, it's to the -1/2. What does the negative exponent do to an existing fraction? Flips it. So now it's going to become 4 over 25x squared y to the 12th to the positive 1/2. And then I'll square root the 4 and the 25. And then x squared to the 1/2 is x. And y to the 12th to the 1/2 is y to the 6th. Is that okay? Anya? Braden?
So why is it 12 in the other problem? In the first problem?
Oh, it should have been 6. Thank you. Yeah, it should have been 6. I don't know why I was thinking that. It's 12 times 1/2. Yep. Thank you. All right. We fine? Well, I have another piece of good news for you. I have some review materials for you, but we're not going to use it today. I want you to take these and put them somewhere safe. Well, I shouldn't say that. We might get to these today, but I don't think so. But we might. So keep them handy. Alright, everybody get one? Set that aside because there's something else we need to do first. Next time we're together, is that Monday? We're going to have a quiz.
Monday quiz?
Next time we have class, so if that's Monday, that's Monday, our next class period.
Yeah, we don't have it Monday, we have Tuesday.
I called.
That was all
And
good.
here are some practice problems to prepare us for the quiz. Okay, so we have not quizzed over the last two sections yet, so that's what we're gonna do. This has a lot of problems on it. The quiz, I haven't written it yet, but I don't think it'll probably have this many problems on it. But these are the kinds of problems that will be on it. Okay? This is also excellent test review because all of these things are going to be on the test also. Our test will be sometime the end of next week. I will keep you posted. I get my act together, we have to figure it out. Okay, so here we go. 72 times 1/2 to the x over 3 equals 9. This is a practice quiz, all kinds of random problems. This is
Pardon the interruption. Is Amanda Leon in the classroom?
she is,
And her assistant services?
yep,
Thank you.
come back. Hello. All right, so what's step 1? Divide by 72. You guys, that's a common theme for us. You do not want to have a number hanging around in front of an exponent, an exponential, or in front of a logarithm, either one. You don't want to have that hanging around. So we're going to divide by 72. So we have 1/2 to the x over 3 equals, now what about 9 over 72? Anya? It'd be 1/8. If you don't get to use a calculator, this has to be rigged. What is special about 1/8? It's 1/2 to the 3rd power. Remember, 8 is 2 cubed. So 1/2 to the x over 3 is the same as 1/2 to the 3rd. Which means what? X over 3 has to equal 3, which means x equals 9. If it's a no calculator problem, kids, you have to be able to do that. There has to be a connection between these two numbers. Okay. B looks very much the same. What's step 1? Divide by 2. Is there a connection, some kind of relationship between 4 and 8? Now, don't say 8 is 4 times 2. That's not the kind of connection we want. We need an exponent connection. Eli?
4 is 2 squared and 8 is 2 cubed.
This is 2 squared, and this is 2 cubed. 8 is not a power of 4, at least not an integer power of 4. So I change them both into 2's. These are now the same. So my exponents are equal, so 2x plus 6, that's a multiply, so it's a distribute, equals 3. It looks like negative 3 halves, if I didn't make any mistakes there. Is that right? All right. So those two problems are virtually the same. All right, next, this one is not the same. What are we going to do with this? Subtract the 3. Absolutely. You need to get this guy right here by himself. So you gotta get rid of that 3 and And then what else do we need to get rid of? The 2, so we'll divide by 2. Are you keeping up? Is everything okay? Now what? Loop-de-loop. Whenever you have log equals a number, you're gonna loop-de-loop. You're gonna start with the base, always, always, always. So 6 to the first equals x minus 1, which means x equals 7. So far, we're gonna ace this quiz. All right, D. Katie?
I set it up like log base 3 and then multiply that x plus 1 times 4.
Just wait a second, you can finish, Katie, but let's let everybody, make sure everybody's on board with her plan. Remember, you can't have 2 logarithms and solve the equation, it's not possible. So the first thing she did was say these 2 have to go together. They have to combine into 1 logarithm. Since that's a plus, when I combine them, they will go together as a multiply. So this is gonna be 4x plus 4. These are being multiplied. Now, the problem we just did, we ended up with a log equal to a number, so we loop-de-looed. Katie, what did you do with this? That is a different situation.
Divide by the log base 3 on both sides so that you just end up with 4x plus 4 equals 9.
Right. Now, I need to be a legit math teacher here. We can't divide by log base 3. Log base 3 doesn't exist without a number attached to it, but she's exactly right. If the log of this is equal to the log of this, basically I can drop those. I'm not really dividing them, I'm dropping them. They're just gone from the problem. Sort of like, remember the exponential we did when we had 3 to a power equals 3 to a power, and we just dropped those off? Yeah, that's what's happening. So we're just setting these 2 quantities equal to each other. So 4 equals 5x, did you get 4/5? E, what are you gonna do with E? There really isn't anything to divide by or anything, so how are we gonna solve that one? Loop-de-loop. So it says x to the negative second equals 1/9. Now, some of you just know what that has to be. But if you don't, what does x to the negative second mean? 1 over x squared? So some of you can look at that now and say, oh, I know what x has to be. But if you don't, you can cross multiply. Now can you tell what x has to be? So if you could tell that from the beginning, perfect. If you could tell it from this step, perfect. If you need to go all the way to the end, perfect. X equals 3. One more equation, then we're gonna get our calculators out. Haven't needed a calculator for any of this. One more. Meg, step 1 with this guy, what do you think?
You're gonna divide by, no, you're gonna move the 2 in front of the log, and you're gonna do 3 squared, which will equal
Exactly.
nothing.
Did everybody catch, I snuck a number in here? That number, sometimes I divide it out, but I can't really divide it out because I don't have one over here. So that number is an exponent. So this is the log base 4 of x plus 3 minus the log base 4 of 9.
divided by 9.
Okay, folks, you know what's she doing here? She is taking the 2 logarithms, which can't be, we can't do it with 2. She's putting them together, like that. Perfect. Who can pick up from here? Jaden, can you pick up from here? We have log equals a number. What do we do? Don't be messed up by this. This is log equals a number. What do we do whenever we have that situation? Look at me. Yeah. So we'll start with the 4 to the second equals x plus 3 over 9. And 4 to the second is 16. Uh-oh, this might stretch you a bit with no calculator. 16 times 9, right? I need to multiply 16 times 9. 144 equals x plus 3, so the answer is 141. Is everybody good with the no calculator problems? Okay, all right, here we go. Now we're gonna get our calculators out. And we're actually gonna solve some of the same kind of problems. They just aren't rigged. Okay, here we go. Step 1. What do you think? Divide by 88. Always, always, always get rid of that number. Still 1 over 88. You do not want to try this problem without dividing. It's a lot more of a headache. Now what? Natural log both sides, because if we ln both sides, this goes away. So 2x minus 1 equals ln this fraction. Your job is to get x by itself, so what are you going to have to do? You're going to have to plus 1, so 2x equals ln your fraction plus 1, and then divide by 2. So this is what we're going to type into our calculator. ln 301 divided by 88, close parentheses, plus 1 equals divided by 2. Make sure you're getting 1.1149. If you don't type in with me, you'll never know. Make sure you get that answer. You don't want to do all the work and then get the wrong answer because you don't know how to type it in. You ready for the next one? Here we go. Step 1. Divide by 4. Oh, that actually works. So I can go ahead and make that base point 5. That's nice. This looks like the problem we did before that had like a 4 and an 8 or something in it. But the problem is what? There's no way to make 7 and 5 the same number. So we need our calculator, and specifically we need to do what to both sides? Logarithm both sides. You can ln. If you want to ln, you absolutely can. There's no advantage to it, but it is perfectly okay. Perfectly okay. What happens then is, this guy comes out in front now. So we have x log 7 equal to log 5. That's how we get the x down on level with everything else. So then what do we type into our calculator? Log 5 over log 7. Go for the closed parentheses. 0.8271. If you ln, kids, you'll have ln 5 over ln 7, and that is exactly the same number. It really doesn't matter which base you use. All right, 300 over 1 plus 82 e to the negative 0.7x equals 180. Solve for x. Who's got a thought? Peter.
Multiply
By?
180, 1 plus 82.
So take this guy over here.
Yeah.
Yep. So 300 equals 180 plus 180 times the 2, 14760 e to the negative 0.7x. Okay, everybody see what happened? We multiplied this over to here. So it became a distributive, and we ended up with this. Guys, you have to be able to do that by yourself. Did you follow what I did? Everybody fine? All right, now what? It's still a mess. I need to solve it. Now what? Subtract 180, so 120. Big?
And then you're gonna divide by 14,760.
Yep. So actually I can lose a zero, so 120 over 14,760 or 12 over 1,476. If you leave the zeros on here, that's fine. Please don't let that confuse you. Meg? ln both sides, take the natural logarithm of both sides. So we have the natural log of this fraction equal to negative 0.7x. So x will be this guy divided by negative 0.7. Did you get x equal to 6.8745? Yes? Someone nod at me.
Yeah.
Thank you. All right, log base 12 of 19. What? Loop-de-loo, I can absolutely loop-de-loo this, however, it's gonna give me this, which is absolutely fine, but I'm nowhere near done, because what am I gonna have to do?
Move the x over in front of the 12.
And the only way I can do that is if I put the logarithm of both sides. That's exactly right. So loop-de-looing removes this logarithm, but then I end up having to put another logarithm in. But I can type this one in on my calculator. Log 19 over log 12. Log 19 divided by log 12. 1.1849.
Yeah.
Thank you, I heard some yeses, that's good.
You know what log like actually is? You know how like pi is 3.8 or whatever, you know, is log like an actual number?
Well, log by itself doesn't exist.
Okay.
It has to be attached to a number, so that is an actual number. But LOG by itself is nothing. Nothing. It's a different way of writing an exponential.
Then what's log 1?
0.
What's log 2?
I don't know, I don't know. There is a whole table that I had to use when I was a kid, because we didn't have calculators, where you can look up the log of 2 in the table. It's a decimal like this right now.
Who created logs?
Napier, a guy named Napier, and they weren't really created, it was just a different way of writing an exponential. Yeah. Yeah. They were actually, when he first did it, they were called Napier's bones. That's what the logarithm table was called.
When were they created?
Why?
No, when?
Oh, I don't know when. It was a long time ago. But I don't know the exact year. That would be easy to look up. They were, originally, the point of them was to help with calculation. And they're still helping us with calculation because there are numbers too big for your calculator to handle. I don't know if you've ever been messing with your calculator and it says error overflow. That means the number you put in is too big. So we can handle those only using logarithms. Now, we don't have much use for numbers that huge, but like astronomers do, you know, if you're talking about great distances or whatever. All right, here we go. All interesting stuff. Napier, Google it. You'll find out about it. All right, here we go. What do we do here? Divide by 2. So the log base 18 of x equals -2. And then what? So 18 to the -2 equals x. And we can either say 1 over 18 squared and figure out what that is, or we can give a decimal. So 18 raised to the -2, the decimal would be 0.0031. 18 squared is 324, so 1 over 324. With that problem, you could answer it either way. Either way is fine. All right, one more, then we'll start our word problems. All right, log base 3, 2 minus x equals root 2.
We log base 3 divide by the log base 3 first.
You can't divide by log.
Okay.
It has to have a number attached to it. So if you wanted to divide by log base 3 of 2, that would be okay. But we can't divide, this doesn't exist.
Like if you were on that one, it has to be the whole 2 minus x.
Yep.
Okay.
And what point would that be? It would just
Yeah.
put it over here, right? What do I do whenever I have log equals number? Loop-de-loop. So 3 to the root 2 equals 2 minus x. Remember, I got a calculator, so I'm just gonna type 3 to the square root of 2 power equals 2 minus x. But I'm solving for x. So what do you suggest?
Subtract 2.
Subtract 2.
And whatever your answer is, the opposite.
And whatever your answer is, divide, make it the opposite, or basically you're dividing by -1.
Yeah.
So this is what we're gonna type in. -3 raised to the square root of 2 power plus 2. I got, see if this is what you got. I got -2.7288.
There's something that's supposed to. Oh, no.
All right. need you to get your notes out because, you'll need the FV and PV formulas, and they're in your notes. Remember?
Then you're good on notes, on your
Hey, let's go.
Oh, I also put them on the review sheet, so if you still have your review sheet out, they're down here at the bottom, right there. You do not have to memorize those, so you'll have them. Here are the other two over here that we use.
That's always math problem.
So, read question number 1, or G. Read question G.
Just one. I have a question going back to that. Like, on that one, you had to I got a different answer because I did a 3 to the square root of 2 minus 2 all at once, and I got a different answer. But then earlier, I was doing it like separately, not being different answer. So how do you know when you have to like get the answer first and then do?
Okay, wait, I'm confused by your question. So, is this what, I'm trying to
I
read
put
what I
that
had.
whole thing in my calculator at once.
Okay, is this what I had as the answer? This was gonna be X?
Yeah.
So this is what you put into your calculator?
Yeah.
Okay, so did I might have done it wrong. So -3 raised to the square root of 2 power plus 2. Oh, I bet I know what happened. When you raised to this power, it put parentheses here. Did you close that parentheses?
Oh, probably not.
Yeah.
Okay.
You need to,
Okay.
because that too is a part of that square root.
Okay. Thank you.
Got it? Yeah. Anytime the calculator puts a parentheses in for you, pay attention to that, because you're usually gonna have to close it before you continue on. Alright, so problem G. Read the question very carefully and figure out which formula you're going to use. Lauren, what do you think? FV. We are using FV because what is Kamara doing? She is making a payment every month with a goal of accumulating for the future. Right?
Are these, equations that you give us on the test?
I've already answered that question.
Did you?
Yes,
Okay.
these two are, those you need to know,
Okay.
these two are. Okay. So here I'm ready to go, I need to know what all these things stand for. How much will she have in her account? Isn't this what I'm looking for?
Yeah.
This is R in both PV and FV. R is the payment amount, so her payment is $32. Her interest rate is 0.0215, but I have to divide that by 12 because those payments are going in 12 times a year, monthly, right? Yep. She continues to save for a total of 22 years. So this exponent is going to be her total number of payments, which is going to be what, Robbie?
264.
And how did you get 264?
You multiply 22 times 12.
22 times 12. She's making 12 payments a year for 22 years. Would you agree with this setup here? So now we just need to type it in, as awful as it is. I always do my numerator first. 1 plus 0.0215 divided by 12, close parentheses, raised to the 264 minus 1 equals, divided by parentheses, .0215 divided by 12 times 32. I'd like some confirmation, because you've witnessed my mistakes, so what do you think? Anybody else get that? That's the value of her account.
Thank you, Mara.
All right, number 2. Read it. Which formula, you okay with it? All right. Which formula do we need? PERT. Why is it PERT? Because it's not money. Kids, if it's not money, the only formula you have is PERT, and that's the one that will work. This will give you the answer to every non-money problem we do that involves growth and decay. So what goes where? What's the 92? P? What's the 1920? A? What's my R? Don't know, but T is 14? How do I solve? Divide by 92, absolutely. ln both sides, take the natural logarithm of both sides. So ln 1920 over 92 equals 14r. And then I will get my r. Did you get 0.2170? Someone? Anyone?
Yeah.
Thank you, thank you, thank you. All right. Next one. Read the question and figure out which formula you're gonna need. Not FV.
She literally just wrote the.
We need PV. Why do we need PV? What's happening? We are paying off a loan that right now, its present value is $3,000. It is not growing. Hopefully it is shrinking, right? That's what's happening here. So, we need PV. I need everybody to understand the difference between Kamara's problem and Van's problem. Does everybody see the difference? All right, here we go. What do I know in this problem? What do I know? I know the present value of the loan is $3,000. I need to figure out what the payment is, so R is gonna be the variable. R is gonna be my unknown. The interest rate is 0.035. And he is making monthly payments, so we'll divide by 12. How many payments is he going to make total?
24.
24, but that's negative in the formula. Over 0.035 divided by 12. Everybody okay? Now, this is one where we're gonna go ahead and type this in like we did before, but then we're gonna have to divide both sides by that to get R by itself. So, I'm gonna figure that out first. I always do my numerator, 1 minus parentheses, parentheses, 0.035 divided by 12. For this thing, I got 23. Maybe you didn't stop, I don't know. I got 23 here. So now I'm gonna do 3,000 divided by that answer. I got his payments to be $129.61.
Yeah.
Anybody else with that? No? Yes? I just need a little affirmation there. Now, if you're not getting that, try again. Type this in. After you get the numerator typed in, it equals, divided by this quantity, equals, and then do 3,000 divided by second answer. Answer button right down here. Anybody besides Eli get $129? Good, okay. Last question, this is Meg's question. Which formula do I need? I need my compound interest formula. That's what I need. So, do I have an A? I'll write it down. Do I have an A? I want to end up with 1,000, don't I? Do I have a P? 399. Do I have an R, an interest rate? 0.015. And it's gonna be divided by 4 because her bank compounds quarterly. Meg is not making payments, you understand that? Meg goes down to the bank, hands them $3.99 and comes back at some point when she has 1,000. Because the variable is up here, I'm going to need logarithms. That will not be step 1 though. What will step 1 have to be? Divide by 399. This looks terrible, but it's easy to do because we have a calculator. We can ln both sides or we can log both sides. There's no benefit to either one. Nothing's going to cancel. I am a creature of habit. I'm gonna log. You can ln. It makes 0 difference. The purpose of doing either one, the purpose of introducing a logarithm is so that this guy comes down. You can't solve him when he's an exponent. So we'll bring him down. I know this looks terrible, but you can do this if you just stop and think about, this is what you're trying to get by itself, right there. Think of a regular equation. What are you gonna have to do with that 4? Divide it? So we're gonna have to divide this by 4? What are you gonna do with this? Divide it? So I'm just gonna take my calculator, I'm gonna type in this guy right here, log 1,000 divided by 399, close the parentheses, divide that by 4, and then divide by log 1 plus 0.015 divided by 4. I need confirmation. I got a pretty big number. I got 61.3677
Yep.
years.
What?
61.3677 years it's gonna take. Well, I didn't intend for that to take all period, but we got in a good review. the quiz will not take all period. Okay, guys?